All right, notes 3.4 are on multi-step equations. If you look at the top of page 6, it gives you a list of steps to solving multi-step equations. Instead of using this list, I would rather you look at the flowchart on page 2 instead. Please write this down in your chart. If you need to press pause, please go ahead and do so. This is extremely critical that you have this written down right here, okay? So page 2 of your notes looks like this right here. All right, so I want to go through this flow chart with you, but first thing I want you to do is, if you notice this piece of advice right here, it's not really a piece of advice, it's something you really need to do. Please add this onto your paper. It says, if there are fractions, get rid of them by multiplying through by a common denominator. Again, if you need to press pause to get this written down, make sure you do so before you listen to some of the stuff that I'm going to tell you. All right, so this equations flowchart will tell you exactly what you need to do while you're solving an equation, all right? So you're going to go through and you're going to ask yourself these questions. The first thing you're going to do is you're going to say, are there parentheses? If the answer is no, you go on to the next question. If the answer is yes, then you're going to distribute through, okay, which is what we learned in our last video. Next thing I want you to do is go to this question this step right here. If there are fractions, get rid of them by multiplying through by a common denominator, okay? Then you're going to ask yourself, can I combine like terms, exactly the same variables on either side of the equation? If the answer is no, you move on to the next step. If the answer is yes, you're going to combine like terms, okay? Now this is where things get new. Are there variables on both sides of the equation? If the answer is no, you are going to move on to the next question, all right? If the answer is yes, you're going to move them to one side of the equation using inverse operations. Remember, we know inverse operations, like the inverse of addition is subtraction, for example, okay? Then you're going to find out, is there a number or constant not attached to the variable on the same side as the variable? You do this all the time. If the answer is yes, you're going to move the number to the other side of the equation using inverse operations. And then if the answer is no, you move on to the next step. Lastly, you're going to ask yourself, is there a number attached to the variable? If the answer is yes, then if it's attached by multiplication, you're going to divide. If it's attached by division, then you're going to multiply. And if it's attached as a fraction, then multiply by the reciprocal, all right? Now, what I need you to do, please, is have this flowchart easily accessible, flip back and forth between what we're going to solve and this page here, and I'm going to show you how this flowchart is extremely useful as we do our work. All right, like I said, we're going to flip back and forth between the questions on page 6 and the flowchart on page 2. So question number 1 says 5 times x plus 3 in parentheses plus 3x equals 2x minus 12 plus 3x. Again, you have to make sure that you are leaving each side of the equation alone until you get to a point where you're starting to do some inverse operations. So let's follow our flowchart. The first thing it says is, are there parentheses? So right here, are there parentheses? Absolutely. So the answer is yes. We go to what we should do. It says that we should distribute. So let's go ahead and do that. So I'm going to go through and I'm going to distribute this 5 on the outside through. Okay? So I end up getting 5x plus 15. And then I just copy the rest of the equation down. Again, do not forget this step of actually copying the rest of the equation down. All right? All right, so now let's look at the next question. So we've done this piece right here. Next question. If there are fractions, get rid of them by multiplying through by a common denominator. We don't have any fractions in this equation, so we can skip that step and go on to the next one. Next step, can you combine like terms, exactly the same variable on either side of the equation? So let's look and see. So on the left side, are there any like terms that I can combine together? Absolutely. This 5x and this 3x go together, so I end up getting 8x. The 15 doesn't get combined with anything because there's nothing like it on the left side of your equation, okay? Look at the right side of your equation. Are there any terms that are like each other? Yes, there are. The 2x and the 3x are like each other, so I have 5x, and then I'm just going to copy down this minus 12, okay? Next question in the flowchart. So we've said yes to this combine like terms. We're done. Next question, are there variables on both sides of the equation? So let's take a look and see. There are. We have 8x on the left side and 5x on the right side. So let's see what we should do with those variables? The answer is yes. Move them to one side of the equation using inverse operations and then combine them on that side. So let's go ahead and figure out what side we want to do it on. Well, it doesn't really matter, it's up to you, but I tend to prefer to put it on the side that has more x's. So the left side has more x's than the right side, so I'm going to get rid of the 5x on the right side. Well, it's a positive 5x, so to get rid of it and make it nothing, I'm going to subtract 5x. Dividing by 5x does not completely get rid of it for me, so that's not useful. This goes away. This turns into 3x. And then I copy the rest of the equation down. This is what it means by combining the variables on one side of your equation. All right? So then, let's go to the next question. Is there a number or a constant not attached to the variable on the same side of the variable? So let's look and see. The side that the variables have chosen is the left side, and there is a number attached to it on the left side. Sorry, there is a number on the same side, but not attached to it. And that number is 15, so I'm going to get rid of the 15 because it says yes, move the number to the other side of the equation, and then combine / simplify. So I'm going to move this 15 to this other side right here, and in order to be able to do that, I just am going to subtract 15 from both sides. Now I'm going to combine or simplify the right side of my equation. So I end up getting 3x equals negative 27. Now all I have to do is divide both sides by 3. Let's go to the next step in our chart. This is stuff you already know, but we'll just go through the chart so you can understand it. Is there a number attached to the variable? Yes, there is. It's the 3 that's in front of the x. If attached by multiplication, then we divide. So that's what we're doing right here. So I'm going to divide both sides by 3, and that's how you end up getting x equals negative 9. Okay? All right. We're going to go through the flowchart again for the next question that we have here. So question number 2. Let's start right at the top of our flowchart. Are there parentheses? The answer is yes, so we should distribute. So let's go ahead and do that. We have 1/2 on the outside. Again, think about this logically. What's 1/2 of negative 4? It will be negative 2, right? Take 4 and cut it in half, you get 2. Take negative 4 and cut it in half, you get negative 2. And then 1/2 of 6 is 3, so 1/2 of 6x is 3x, all right? Then I'm going to copy the rest of the problem down. That doesn't require me to distribute, okay? Over here, I'm going to distribute this 2/3 through. Well, 2/3 times x is 2/3 x. And I'm not quite sure what 2/3 times 9 is, so I'm going to do the workout for it on this side. So let's figure this out. It's really 2/3 times 9 over 1. So multiply across, you get 18 over 3, which is 6. But I want you to think about it logically. You know that 1/3 of 9 is 3, so 2/3 of 9 should be 6, okay? So you end up getting negative 2 plus 3x equals 1/3 x plus 2/3 x plus 6. Now let's look at the next thing. The next thing is what we added on. If there are fractions, get rid of them by multiplying through by a common denominator. Now watch this very carefully because this is where some people get a little bit confused. So I'm going to go through and get rid of my fractions by multiplying by my common denominator. Well, the only denominators I have are 3, so finding my common denominator is easy. It's just 3. But I have to multiply each term by 3. And remember, what separates my terms are addition and subtraction signs. So I have 1, 2, 3, 4, 5 terms, which means I'm going to have to multiply by 3 5 times. All right? So I'm going to multiply this by 3, this by 3, this by 3, this by 3, and this by 3. Okay? So 3 times negative 2 gives me negative 6. 3x times 3 gives me 9x. All right? This 3 and this 3 cancel each other out, so I end up getting 1x. This 3 and this 3 cancel each other out, so I end up getting 2x. And then 6 times 3 is 18. All right? Now I can go through and finish the rest of this problem up using my flowchart. The next thing I'm going to do is see if I can combine like terms on either side of the equation. Yes, I absolutely can, so I'm going to combine my like terms. Let's see what like terms we have. On the left side of the equation, nothing is like each other, so I'm just going to copy it down exactly how I see it. Okay? And then on the right side of my equation, I have 1x and 2x, which add together to give you 3x, and then add 18 to both sides. okay? The rest of this is all review for you for the last several lessons, but let's just follow through with the flow chart. So the next thing it says is, are there variables on both sides of the equation? Yes, there are. We have 9x on this side and 3x on this side. So if the answer is yes, we'll do what it says. Move them to one side of the equation using inverse operations and then combine/simplify the variable side of the equation. All right, so let's go ahead and do that. I'm going to get rid of the 3x because there's less on this side than there are on this side. Again, you don't want to divide by 3x. That's not helpful. I'm going to subtract 3x from both sides. All right, so I end up getting, this -6 just gets carried down, and then this becomes 6x, all right, equals, now 3x and -3x cancel each other out, and I know that because 3 minus 3 is 0, so I get equals 18, all right? Now it's just a regular two-step equation, but let's follow the flow chart. Is there a number or a constant not attached to the variable on the same side of the variable? Well, the variables have chosen to claim the left side, so the constant right here has to go. So how do I get rid of a -6? I'm just going to add 6 to both sides. This goes away, so I end up getting 6x equals 24. I would follow the next step in the flow chart, but at this point in time, I'm hoping you understand that you're just supposed to divide everything by 6, and your answer is x equals 4, and we are done. All right, please take a look at question number 3. We will see what we have to do using our flow chart. So start right at the beginning of our flow chart again. Are there parentheses? No, there are no parentheses, so I can go on to the next question. If there are any fractions, get rid of them by multiplying through by a common denominator. So right here, my common denominator is going to be 10 because it's the only denominator I have. I have 1, 2, 3 terms, so I'm going to multiply everything through by 10. So that means I have to multiply by 10 3 times. So this is going to have times 10 right here. This is going to have a times 10 right here, and this is going to have a times 10 right here. Well, 10 times x is 10x. And this 10 and this 10 cancel each other out, so I end up getting x equals 44 times 10 is just 440, right? And this is something you should easily do in your head, especially since we did a whole unit on scientific notation, okay? Now, let's look at the next question. Can you combine like terms on either side of the equation? Yes, I can, so I'm going to combine my like terms. So these combine together to give me 11x equals 440, okay? Next step. Are there variables on both sides of the equation? There aren't, so I can go on to the next question. Is there a number not attached to the variable on the same side as the variable? No, there isn't. So the last question, is there a number attached to the variable? Yes, there is. The number that's attached to the variable is 11. It's attached by multiplication, so I'm going to go through and divide. Okay, so divide by 11, and you end up getting x equals, let's figure this out, 11 into 440. Well, 11 doesn't go into 4, but 11 does go into 44 4 times. 4 times 11 is 44. Subtract it, you get a 0. Don't forget to bring the 0 down. 11 goes into 0 0 times, so the answer to this is x equals 40. All right, you guys, number 5 is exceptionally tricky, so please be really careful as we go through this question together, okay? You have fractions. So you want to get rid of your fractions immediately. The way we're going to do that, just like we saw in our flow chart, is that we are going to get rid of them by multiplying through by a common denominator. So I have a denominator of 3 and a denominator of 2, which means that my common denominator would have to be 6 because 3 times 2 is 6 and they have nothing else in common. So I'm going to multiply everything through by 6. But now this is where things get tricky. I want you guys to write this down on the side so you don't get confused by this. See this 6 right here? I'm going to multiply 6, but the denominator is 1 technically, right? So I'm going to multiply 6 over 1 by 2x over 3. Okay? Well, this 6 and this 3 both are divisible by 3. So when I divide 3 by 3, I get 1. And when I divide 6 by 3, I get 2. So this ends up becoming 2 times all of this right here, this 2x right here. And then it's technically over 1, but anything over 1 is itself, okay? Hopefully that makes sense to you. Let's do the next one together. So the next one is 6 over 1 times 2 plus x over 2. Okay, again, see what's in common. Well, 2 and 6, are both divisible by 2. When I divide 2 by 2, I get 1. When I divide 6 by 2, I get 3. So I end up getting, don't forget to copy down this minus sign, minus 3, and then I need parentheses around this 2 plus x because it's the entire thing. All right, and then the other side of your equation is easy. Negative 4 times 6 is negative 24. So this is your new equation. Now, before we move on, the whole point of multiplying by a common denominator is to get rid of your fractions. If you still have fractions, you did not multiply by the common denominator correctly. Now that you've done this, the rest is easy peasy. We've already done this stuff before. 2 times 2x gives you 4x, and then negative 3 gets distributed to this 2, so you get negative 6, and then this negative 3 gets distributed to this x, so you get negative 3x equals negative 24. Okay? Combine the 4x and the negative 3x, you get x minus 6, just copy that down, equals negative 24. All right? One last step, just add the 6 to both sides, and you get x equals negative 18, and you are done. If you have any questions about this, please make sure to ask me next time I see you in class, because this is a very difficult concept. Have a good one.